In this tutorial today, I'm going to describe how we would go about creating a fairly large model of an enzyme. I'm going to be using the program VMD. This is a program that you can get through the University of Illinois. It's freely available. A little bit of a learning curve to start using it, but once you kind of get the hang of it, it's not too bad. It has several different windows. It has the visualization window that allows you to kind of see what you're doing. Has this script window, so you can enter script commands, which we'll be doing a little bit of. And then it has the main menu that allows you to open up a range of other windows as well. Predominantly we'll be going back and forth between these, and also the first thing I'm going to do here is load my molecule that I'll be working with. I put quite a bit of work into this already, trying to get a picture of what I would do. I'm not going to go through exactly everything I did in detail, but I will be hopefully giving you enough information so that you could do your own types of projects similar to what we do here. This is a nitrogenase model here that we're going to put together. It's going to load this visualization state, which is going to take a little bit of time. Bases this visualization state on the actual molecule model, which I loaded in already. You're going to want to make sure that as you're saving things, that each day when you're done, you're going to want to save your visualization state so you can kind of come back to where you're at. Now, the benefit of this visualization state is it really does allow you to sit and manipulate, so you can break things apart and decide how you want to print these. One of the first things you got to do with VMD is go to display and turn this axis off. I find that somewhat annoying to be looking at. This is the molecule that I'm going to be trying to print, which is a very, very large protein overall. I could print it as something like this. It would be very brittle, not very tough, and wouldn't really show a whole lot of details of what I want to show. What I want to do here for this example, I want to do a fairly large structure and then have quite a few different features that I can show and look at as I'm evaluating this. So if you go under graphics and representations, as I said, I've done quite a bit of work ahead of time. I'm going to try and describe some of that. One thing I've done is I've broken this up into sections. I'm showing these ribbons, but I can click on these and bring them back and forth. That's because this is it's a heterotetramer, and this is showing one side. I've broken it into a dimer because the two sides are basically equivalent on this, and so I can pull these off, or I can show them. And what I really want to do today is I want to print a section of this and just kind of show you how I would break this up. I've already done quite a bit. I've got several different components here broken up, so you can see, like, here's one section that I've gone through and just selected only chain A and residues 4 through 54, and then I've done that for various components to just tie these pieces together. If I open up all these different components that I've kind of selected here as I've broken them up, then slowly we would replace all of this background. You don't need to show the CPKs. But now if you look at this, you can see that everything that was being shown here with this wire model is now kind of covered in the various components. And this is one of the things I did to kind of break this up. Another thing I want to do is I want to show a few of the pieces of this protein as more focusing on the heteroatoms that are in here. And so I've drawn those in, as well as how they're linked up to some of the various components. And for some understanding of that, you'd have to know a little bit more about nitrogenase. I'll go through that a little bit as I go through and do the descriptions here. But these are the various pieces I've broken this into. And as I said, I want to print a fairly large model for this. This is going to be kind of a longer term project to build this thing. And so one of the things I'm going to do here is deselect most everything on here. So that I can just break this up into something simpler to work with. Now, one of the ways I broke this one up was just kind of starting from the beginning. You can see this is actually going backwards for this. This is going from residues 480 through 446. And this would be one of my components. And I could print this. This would be very simple, but I'm actually going to go to one of the other regions of this that is going to be a little bit more difficult just to kind of explain what I'm doing today. And that's the next piece here. Now this piece here, the reason I'm printing it today is because, as I said, it's a little bit more difficult. I can click on that. That's the heteroatom that I want to show here. And what I've done, again, getting used to using the VMD interface here, you can click on here. This is this region right now that we're showing of this component that I'm really not that interested in. The other piece is what I am interested in. And I've broken this up into chain A, residues 337 through 447. And also chain A, residues 271 through 282. And that gives me the pieces that are actually bound to the heteroatoms here. And so I click on my mouse, center down here. I can translate this, rotate around. So now I can kind of look at really what residues are surrounding that. This piece is a little bit harder. This takes a while to get used to. And so if I go in here and click on the CPK version, which is this component that I'm showing here, again, I can pull that off or put that back in again. This is broken into chain A, residue 275. Residue 275 in here is the cysteine ligand that's bound here. And I've selected chain A, residue 275, and side chain, which is this piece, or the alpha carbon. And you have to kind of play with this to figure out exactly how you can make it show just what you want to see. I just want to show the alpha carbon, which is going to be bound to the backbone, and then my side chain. Or, you have to watch your ands or ors, otherwise you'll end up getting a lot more molecules than you want to show. My second one is chain A and residue 442. That's the histidine ligand here, histidine 442, and side chain or alpha carbon. So I've got my side chain or my alpha carbon here. Or chain A and residue 6496. And I'm not sure how these things get assigned, but that's what it's assigned a number for this heteroatom. Those you just kind of have to figure out how VMD brings those in. And you can do that somewhat through the analysis. If you click on analysis here, there's a sequence viewer. That will help you kind of figure out what the names of your heteroatoms are sometimes, but I'm not sure how VMD pulls that in. So this is the segment I'm going to be trying to print today, is this piece of this protein. Because I want to be able to put these pieces together, I need to find a way so that I can glue various segments together here. And there's actually, because this is two separate strands, this strand right here and this strand over here that goes along, there's going to be 4 different break points here where we're going to have to glue this section of the model to another section. As I told you before, I've got other sections, so my first section here would be this connection through this. And the way that I'm doing this is I need something that's going to be common in both strands. And so what I've done here specifically, if I can find it, is I've also selected CPK for chain A, residue 446, and either backbone and carbon. That gives me 2 different carbon atoms that make up part of that backbone. I'm showing these at a sphere scale of 3.3. I kind of leave these up here. You can kind of see some of the different features I use when I draw these. And I do that specifically because when I go through and make these 2 pieces, one problem we're going to have when we transfer this into the software program that I like to use, which is an online software program called Tinkercad. But when we try to transfer that in, it's going to have some issues with these edges, and we're going to always end up trimming these. So by putting these atoms in here, in this manner, that's the easiest way I've found to be able to trim this. Now, one other thing that I've done here is I actually, on each of these two strands that I'm showing here, I've made sure that I go a little bit beyond those 2 carbons. So I do that on this one. I also do that on this piece. So I leave myself some extra because it is going to mess things up right here. So you do have to kind of watch out for that. So I've done that here. I've also done that on the other 4 points here. So I'm going to show these CPKs as well. And those are just, well, the lighting's a little bit off. So now you can kind of see, I've drawn this so you can see that where these 2 carbons come in together here. Same thing right here and right here. So I've done this in all 4 different places just so that we can do some trimming on these different pieces so we can glue everything together once we print this off. So this is the actual piece that I'm going to try to print out today. I need to be able to take this into Tinkercad to work on it. And as I said, I've got various different pieces here that I'm showing. So these are the 4 sections I've drawn as CPK. I don't intend to leave these atoms in my model. I do intend to leave this piece of the heteroatom in here. But these are just going to be taken across just so that I can figure out exactly how to cut this so that when I try to glue this piece to the next section, that I have a nice clean cut on both pieces. So I'm going to show you how I'm going to take this over in 3 different sections so that I can line everything up in Tinkercad and then I can make these clean cuts afterwards. So I've shown this. The other piece I'll show you really quickly is kind of the settings that I like to use when I print these out. So I do this as a new cartoon. I change the aspect ratio here to 2.35 and a thickness of 0.72, resolution of 10. For the CPK, especially for my heteroatoms, I find that I like to keep those right around 3 with a sphere resolution of 15. I do find that Tinkercad has a hard time importing the bonds if you try to take the bonds in, so I kind of draw the bond radius down really low and I kind of ignore that. I always print these as spheres. Tinkercad just has some issues with that. You can fix those in Tinkercad using some other techniques. I'm not going to go into that for this one. I'm just going to print these off so that they're all kind of interconnected. You can kind of see that's one of the things that has happened here is each of these atoms should be bound to the other atom, and so that should show up fairly nicely. So we've got all of our pieces here set up and ready to go. We're going to need to be able to import this into Tinkercad. So the last thing I'm going to do, just to show you really quickly, is I know the pieces I'm going to print out. This piece will be on all the time, and this piece will be on, well, I'll kind of interchange them. So my first thing I'm going to do, I'm going to take this entire piece as drawn right now over. One thing I'm going to do is once I've decided to bring this into Tinkercad, because I want the orientation to be the same as far as how this is oriented in space and the XYZ coordinates, I'm not going to sit and grab this and rotate it anymore for the next duration of the 3 different models that I'm going to make here real quickly. I'm just going to leave it as is, and at this point we've got to do 2 things. The first thing we've got to do is we've got to come over here under the script and we've got to tell it to scale to 4.0, and you hit enter, and it's actually going to scale this so large you can't even see it. So you've got to kind of have everything together before you even go to that script and draw that out. Like I said, I kind of have a pretty good picture of how I want to take this in. The next thing I've got to do is I got to click under render, and that's going to open up this window here. What we're going to do is we're going to render this as STL. That's the type of file that we need to be able to do the print. And I'm going to browse through here. I'm going to call this section 1. I already kind of played with this a little bit ahead of time to make sure this would work. And I'm going to hit save. And I'm going to replace that one. Make sure the file has the STL down here. Otherwise, when you go to import it, it's going to be kind of confusing. Then I'm going to hit Start Rendering. I'm going to wait for that to be done. Again, I'm not going to be messing with anything in this window, clicking and rotating around, because that will mess up my files. What I am going to do now is I'm going to go down here, and I am going to take away these pieces here that are my linkages, those atoms that I just drew in there, just so I can combine it. I'm going to change this to section 2, hit Start Rendering, wait for that one to be done. And then I'm going to go turn those back on. But I'm going to take away the actual backbone and the heteroatoms for the alpha beta, the alpha helix and the beta structure, so that I just have only the connections. I'm going to save that as file 3. Hit Start Rendering. That one should go really fast. At this point, we really should be done with our 3 different STL files. So what we need to do is come into our next software program, which is Tinkercad. Now I've already opened up a file in Tinkercad so I can work with this. I've already kind of brought this over so I could kind of make sure everything's going to fit. One thing that I find is really useful in Tinkercad, again, you can get a Tinkercad account. They should be free accounts to most people unless you're a commercial user, and then you may have to pay for it. But for an academic like myself, we can go in and use this for free. I think it's free to most students, most hobbyists. On the grid, I've set up a custom grid based upon my MakerBot that I will be using for doing these prints, and I put in the width and the height of that. It has some random ones that you can use, but I don't think it has my model exactly, so I've kind of drawn this out. And I'm just going to leave that as my grid. Now, I've already brought this in, but I'm going to do it again. I'm just going to delete the model that I currently have in. What I'm going to do is browse and find my first section. And I'm going to import that. That might take a minute. While that's going through and importing, I'm going to come back here, and one thing I can do if I want to see this again is I can hit scale to 0.05. Hit enter, and I can show my window, and I ought to be able to see my pieces again. Again, I'm not going to rotate this or move it around until I know that I've got all my pieces brought in correctly. What I can see here right now in Tinkercad is I can see the sections. Remember the first section I told you I was going to bring in everything, my heteroatoms, my helices and beta sheets that I've got drawn in, and also the backbone carbons that I've drawn in on each of these 3 different sections. And that again is so I can make clean cuts. You can see this is one of the issues why I like to do that, because Tinkercad, when you bring things in, doesn't really know how to clean these up and make them nice and sharp. So we're going to do that ourselves separately using these kind of as a reference. But we also need to bring in 3 more files so that we can do that very easily. And so the other 2 sections I'm going to do, I'm going to browse first of all, find section 2 and import that. We're going to have to wait for that for a second. Once that brings it in, we actually have to put all these different sections over top of each other, overlay and do some merges, which aren't too difficult to do. You do have to kind of get used to doing that. But once you have it all merged and you make your cleanup cuts and stuff like that, then we can kind of orient this afterwards. So this may have one on top of the other. Looks like it does. So I don't know if you can see that. One of my models has the atoms in and one does not. I'm going to undo that because that's actually really nice. It oriented two of them right on top of each other. And that's going to be a nice benefit. So I'm going to browse and bring in my third section, import that. That should come in fairly quickly because that's just these four pieces. Those will not be oriented. I'm going to have to actually rotate those through, but that should be fairly easy to sit and overlay those. So what I'm going to do first of all is grab this, drag it over, and I kind of know where these are at. Like I say, they'll be oriented in the XYZ space correctly, so you don't have to sit and do any rotations. You do need to drag them up and get them so they overlay on top of each other. And what I'm going to do is just try to overlay this one to this one right here. So I'm going to have to kind of drag this up, then zoom in. Move in like that. At this point, it has a snap grid function, and the only way you're going to get these lined up really well is turn that off. Then I'm going to click on this again. I'm going to change the color just so I can see the differences in these. And then finally, maybe it's going to be easier to work up here. In Tinkercad, if you hold the Shift key down, you can actually move your camera position for how you're viewing this. Now I can kind of zoom in. The benefit of zooming in is I'll be able to use this arrow now a little bit better to bring this down and try to set this up in the right place. I'm also going to adjust this in the XY space. Oops. Until I get these kind of like sitting right on top of each other. And it's pretty difficult to get them exactly perfect. You're just going to have to find a point where you're somewhat happy with it. And that may be as close as we get, just because, like I say, it's just never quite perfect. That's probably about as close as we will get. It's not too bad. We're off by just a small fraction. Again, we're using this to help make our cleanup cuts on this piece. And so right now that really orients several different pieces. Remember, there's two pieces underneath this. There's these balls here. There's another section. If I click on, I can make that a hole, so I can see, make this a hole as well. That allows me to kind of see this piece, which I could change to maybe green. I'll probably break up this tutorial at this point and come back with a second tutorial to show you how I'm going to go through and trim these on all these different pieces. Again, I'm going to use those two carbons there to basically bring in a box that will cut them right through that place where these merge. And so that'll probably be the focus of my next tutorial before we get this thing ready to print. You can see I've already kind of got a feel for the size of this just to make sure it will work. This isn't the exact way I would arrange it to print it. I would probably print it fairly flat on the bottom, so I'll do some rotation orientation. But I don't want to do that till I've done the trimming steps here.